Section 12.8. In this section, we're going to cover the counting principle and also the principle of permutations. First, the counting principle. If a first experiment can be performed in m distinct ways, and a second experiment can be performed in n distinct ways, then the two experiments in that specific order can be formed in m times n distinct ways. Essentially, all you have to do is multiply the number of ways m can be created and the number of ways n can be done together. So for example, let's look at this. A password used to gain access to a computer account is to consist of 2 lowercase letters followed by 4 digits. Determine how many different passwords are possible if A, repetition of letters and digits is permitted. Okay, so we're allowed to have 2 letters and we're allowed to have 4 digits, and repetition is allowed. Well, we know in the English language that there's 26 letters, so there's 26 letters for option 1. There's also going to be 26 letters for option 2 since repetition is allowed, and we're allowed to use 4 digits. There's 10 digits that we typically use, 0 through 9, so there's 10 digits for option 1, option 2, option 3, option 4. So using the counting principle, all you need to do is multiply these 6 items together, and that will tell you how many different passwords there are out there. If you do the multiplication, there are 6,760,000 passwords. Question B. Again, we're doing 2 letters and 4 numbers, and this time the repetition of letters and digits is not allowed. So that means for the first letter, there's 26 options, but for your second letter, there's only 25. For your first digit, there's 10 options, but for your second, there's only 9. Your third, there's only 8. And your fourth, there's only 7. So how many possible passwords would there be for that? 3,276,000 passwords. Question C. The first letter must be a vowel, which is A, E, I, O, U, and the first digit cannot be 0. Repetition of letters and digits is not permitted. Okay, so my first letter must be a vowel. There's only 5 vowels out there. Now keep in mind that there are 26 letters of the alphabet, but you are not allowed to repeat, so there's only 25 possibilities for option 2. Now we need to look at our digits. The first digit cannot be 0, so normally we would have 10 digits, but since 0 is not allowed, we only have 9, and repetition is not allowed. So there's 10 digits, you've already used 1, so that means 9 are left. Now 8 are left, now 7 are left. And you would need to multiply these together, which would give you only 567,000 possibilities of passwords. Permutation. A permutation is any ordered arrangement of a given set of objects. So an example would be ways that you finish a race, first, second, and third. Ways that you could elect somebody, president, vice president, secretary, and treasurer. If the order matters, it's considered a permutation. The formula for permutation uses a symbol called a factorial. A factorial looks like an exclamation point, and it tells you to multiply all the numbers from the number you started with down to 1. So for example, if I asked you to do 6 factorial, I would want you to take 6 times 5 times 4 times 3 times 2 times 1 and multiply that together. Just so you know, your calculator does have a factorial button. I can show you how to access that really quick. Okay, I'm going to show you my calculator up here on my computer screen. So if I turn my calculator on, if you would like to access your factorial button, you need to hit the button on the left that says Math. And then up here at the top, it gives you an option for probability. So you're going to need to hit the arrow button over a couple times till you get to probability. If you look at option number 4, that's your factorial key. So actually, when you go to type it in, you need to put your number in first. Oops. So I'll type my 6 first, then I'll go Math, over to probability, down to option number 4, and then you can hit enter, and it'll multiply it for you. If you don't trust it, you can check it. 6 times 5 times 4 times 3 times 2 times 1. You also get 720 that way. So let's look at an option. This is probably something similar that we just did. In how many different ways can 6 different cell phones be arranged on top of one another? So that is simply 6 factorial. So you can do it in your calculator if you want. And there are 720 possible ways to arrange these cell phones. Example 4. Consider the 5 letters A, B, C, D, E. In how many distinct ways can 3 letters be selected and arranged if repetition is not allowed? You can do this as a permutation if you want to. You can also just do the counting principle. There's 3 options for, or there's 3 things we want to select. For the first one, there are 5 candidates. For the second one, 3 candidates. And for the second, 4 candidates, and for the third, 3 candidates. And if we multiply those together, you will get 60. You can also do this in your calculator by doing 5 permutation 3. And I can show you how to access that. If you're going to do this on your calculator, you want to type the 5 in first. Then you're going to go back to the menu that says Math. You're going to go over to probability again. You're going to go down to option 2 that says NPR, that's your permutation. And then you're going to put in your 3 and hit enter, and that will also do the 60 for you. So you can do the permutation formula in your calculator. You can also do the permutation formula by hand. So if you would like to do the permutation formula by hand, it is NPR equals N factorial over N minus R factorial. Or again, you could go into your calculator menu and do it that way with technology. I would recommend probably using technology. Example 5. Using the permutation formula, you are among 8 people forming a skiing club. Collectively, you decide to put each person's name in a hat and to randomly select a president, a vice president, and a secretary. How many different arrangements or permutations of officers are possible? So you first go with the total number of people you have, which is 8. You're going to do a permutation because order makes a difference. If you're the president, you have more power than the vice president. There's 3 positions you're pulling for, so you'll do 8 permutation 3. So if you're doing it by hand, in your numerator, you would have 8 factorial. In the denominator, you would have 5 factorial. You get the 5 by taking the difference of 8 and 3. So 8 factorial is 8 times 7 times 6 times 5, 4, 3, 2, 1. 5 factorial is 5, 4, 3, 2, 1, all multiplied. So if you're doing it by hand, you could just cancel those and then multiply 8 times 7 times 6, which would give you a result of 336. Or if you're using technology, you would type in 8 and then hit Math, over to probability, option 2 for permutation, type in 3 and hit enter. There's another permutation formula, and this permutation formula is if you have duplications in your results. So I'll show you an example on the next slide, but let's first get the formula in. Okay, so the number of distinct permutations of n objects where n1 of the objects are identical, n2 of the objects are identical, ... and r of the objects are identical is found by the following formula. First, you would take n factorial, and then you would divide it by n1 factorial times n2 factorial times n3 factorial, all the way up to however many repetitions you get. So let's look at this example. In how many different ways can you see, can the letters of the word Tallahassee be rearranged? So, So first thing you need to do is you need to figure out how many letters are in Tallahassee. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in your numerator, you would put 11 factorial. Then you need to worry about your duplications. Okay, the T, it just appears one time. So you could do 1 factorial, but 1 factorial is just going to be 1. A appears 1, 2, 3 times. So you'll need to do 3 factorial for the A. L appears 2 times. So you'll need to do 2 factorial for the L. H only appears once, so again, 1 factorial is 1. S appears 2 times, so 2 factorial for the S. E appears 2 times, so 2 factorial for the E. So if you want to write it out by hand, that's fine. 11 factorial is 11 times 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. Another 2 factorial. And another 2 factorial. Then you can start canceling if you want. First of all, multiplying by 1 does nothing. And dividing by 1 does nothing. So you could pretty much eliminate those. Also, you have a 2 on the bottom that you could cancel with a 2 on the top. You have a 3 on the bottom that you could cancel with a 3 on the top. And you could also reduce the 2 on the bottom with the 4 on the top. You could reduce the 2 on the bottom with the new 2 on the top. And you could reduce the 2 on the bottom with the 6 that's on the top. So then you could multiply 11 times 10 times 9 times 8 times 7 times 3 times 5. If you did that, there are 831,600 different possibilities that the way Tallahassee could be rearranged.